So, good morning guys, welcome to NEET WORLD Institute and NEET WORLD YouTube channel. So, in this class now we are going to concentrate on the next topic in the measurements and errors. So, in last class we were talking about what is the least count, what is the significant figure, how to find the significant figure, how to find the accuracy, and what is the relation between the accuracy and what is the relation between the significant accuracy and the significant figure. If accuracy increases, it directly depends on significant. So, because of the significant increases, accuracy has been increased, right. So, if significant figure is reduced, the accuracy also will be reduced. So, this was the thing we have learned in the last class, right. So, the next thing we are going to see is so algebraic operation with significant figure. అంటే ఏంటి సార్ algebraic operation అంటే ఏంటి సార్? ఫస్ట్ ఆఫ్ ఆల్ మీనింగ్ ఏంటి algebraic operation అంటే? See, in starting of the bridge course we were talking about the meaning of algebraic expression or operations, right? Now algebraic operation is nothing but it directly deals with addition, subtraction, multiplication and division. అంటే ఇదే కదా algebraic operation. We are using only this thing to do to perform the and get the values of the given equations, right? So these four are the algebraic operation: addition, subtraction, multiplication and division. అంటే ఈ algebraic operation significant figures లో ఎలా ప్లే అవుతుంది? How the algebraic operation will play a major role in the significant figure and how to find when they are given in the form of algebraic operation. Okay, that's the thing we are going to concentrate. So the first thing is addition and the subtraction. Addition and subtraction, in this what we are going to see is two types. Addition and subtraction have a similar rule and multiplication and division will have a similar rule. The first one is addition and subtraction. When adding or subtracting a measured value, the least number of digits after the decimal among the numbers determines the decimal points. Okay, decimal places in the result. So అంటే సార్ ఇంతలా ఎందుకు సార్, చిన్నగా చెప్పండి. Okay, once we'll see what is the multiplication and division telling, and then I'll tell in a simple word multiplication or division. When multiplying or dividing a measured value, the result should have the same number of significant digit as the variable with the least number of significant digit. Okay sir, మాకేం అర్థం అవ్వట్లేదు, మీరు ఇంతలా చెప్తున్నారు. I'll tell you. Addition or subtraction multiplication or division, ఇదే కదా మనం చూసింది. సో ఓన్లీ వన్ పాయింట్ టు రిమెంబర్ ఇన్ అడిషన్ సబ్ట్రాక్షన్, ఓన్లీ వన్ పాయింట్ టు రిమెంబర్ ఇన్ మల్టిప్లికేషన్ అండ్ డివిజన్. సో అడిషన్ అండ్ సబ్ట్రాక్షన్ లీస్ట్ డెసిమల్ పాయింట్, అంతే. లీస్ట్ డెసిమల్ పాయింట్ ఏది ఉందో దీనికి నేను తీసుకోవాలి, అంతే. ఓకే, దట్స్ ఇట్. హియర్ లీస్ట్ సిగ్నిఫికెంట్ figure, least significant figure or significant number. Okay, this is the 2 points you should remember: least significant figure or number for the multiplication or division, least decimal point for the addition or subtraction. Now going to the point here. Okay sir, example. Okay, I have taken from the thing example they have given 1.2 plus 3.45 plus 6.789. If I add everything, how much I will get? 9, and this is 8, 13, 1, and 5, 12, and 14, 4, 1, 4 already, it is 11, 11.439. Addition key ledu subtraction key. What is the thing I have told? Least decimal point. Out of these three things, which one is having least decimal? This is having 1 decimal, this is having 2 decimal, and this is having 3 decimal. Least decimal is 1. Then I should have the result as also with a least decimal only. Only 1 decimal. Cancel this one. So answer is 11.4. 11.4. Getting? So try the example 2. Try the example 2 by your own. Done. So when we are doing this one, 12.63, 10.2. Subtraction means this is 3, this is 4.2. Least decimal, there is 2 decimal, there is 1 decimal. So I should consider 1 decimal, 2.4, 3 you will leave it. So 2.4 is the answer. Multiplication or division. When multiplying or dividing, I told we should consider least significant. Sir, inta with the example enduku sir? Like this much big example, no need sir. Tell one small example, then we will try this one sir. Okay, I will tell. 7.4 into 2.3. Okay, 2.11. Simple. 7.4 into 2.11. Okay, or else you can take 2 also, no issues. 2 also. 7.4 into 2. What will you get? 7, 2 times 14, 4.4, 2 times 8. So I will get 14.8. Least significant. In this, which is least significant? This 2 significant, this 1 significant. Then consider this total term for the 1 significant. First one 1, this 2 you take it as 0. Katam. So only 1 is the answer. That's it. Only 1 is the answer. No need to do anything. 1. I will round off to 1. That is my answer. అంటే ఇప్పుడు ఇక్కడ చూసినామంటే 1.2 into 36.72. If I multiply, we will get 44.064. How many significant there for first one? 2 significant. How many significant is there for the second one? 4 significant. Which means this is 2 and this is 4. This one is 1, 2, 3, 4, 5. 5 significant. Which means I should not have the 5 significant as my answer, either these 2. In this 2, which one? Least significant. 2 is my least significant. So cancel 0, 6, 4. The first 2 is my answer. 44 is my answer. Got it? Okay. The next one we'll see. These are the small examples. You can try it. You can take 2 minutes time and give a try for this 2 question for addition or subtraction, whatever it is, and 2 question for the second one. So in this I will give the trick least decimal. In this I should use least significant. Okay, give a try first. We can go for the next one. 30 seconds completed. Don't take more than 30 seconds for first question. Don't take more than 30 seconds for the second question. Like I have given 2 minutes time. So 30 seconds for each question. You should have completed, I guess. Done. Last 30 seconds. Next one we'll talk about the types of errors. Till now we were talking about the measurement, how to measure the measuring the quantity, how to take that significant. Now we'll talk about what are the types of errors are there. Okay. I hope you have completed. Okay, we'll go for the next one. So, types of errors is the topic now. Permissible error. Permissible error means what? Permissible error is a maximum allowable error. Ante you are doing some work. In that work, you can do 1 or 2 mistakes. That's it. More than 2 mistakes, it is not allowed. Okay. So those kind of mistakes is called as permissible mistakes. It is allowed to some limit. Okay, that is the permissible error meaning. Permissible error is the maximum allowable error in the measurement. So, which is acceptable for the particular instrument or measuring device. It is based on the device. The thing is, it is based on the device which we use. Third one, it is also called as least count error. Ante least count gurinchi manam chusam kada in the starting slide only. What is the meaning of least count? Okay, the minimum measurement which I can measure from the given scale. Least count error or smallest error that can occur due to the limitation of the instrument precision. Okay, for example, if you see, if we measure a length of L is equals to 26 millimeter, then maximum value of true value may be 26 plus 1 or 26 minus 1, which means they are saying that you can measure plus 1 or minus 1. The limit will be only up to that. Okay, if you are talking about 26, it can be 27 or it can be 25 also. So 25 to 27. Suppose if you are talking about 11.5 centimeter and they are talking about you can have maximum of plus or minus 0.1, which means 11.5 plus 0.1, 11.5 minus 0.1, which gives us 11.6, 11.4. So I can have the value from 11.4 to 11.6. It can be any value. 11.4 also possible, 11.6 also possible, 11.5 also possible. It can be any value. Okay, that is the meaning of permissible error. That is the meaning of permissible error. Suppose if we are talking about in terms of kgs, 72 kg sir. Ante you are going for gym and your trainer is asking you to maintain between around 72 in the sense plus 1 or minus 1. In between 71 to 73 you can maintain your weight. According to your height, your BMI, body mass index, should be this much only, which means I can write like this, no, 72 plus or minus 1 kg. Ante meaning enti, I can maintain my weight between 71 to 73 kg, right? That is the meaning, right? You are going for a gym and your trainer told you to maintain around 72, which means you can be plus or minus 1. It can be 71 also, it can be 73 also. So if you maintain between this, your BMI will be good, he is telling. Yes, no? So based on that condition, we have written 72 plus or minus 1 kg. Got it? Yes. The next one is classification of errors. Like permissible error is the first one. The second one, we are talking about systematic error, random error, absolute error, mean absolute, relative. In this class, we will particularly talk about the meaning of systematic and random errors. Okay. I hope you got the meaning of the permissible. Right now, the basic meaning of the permissible error, how to write an equation. Once we are doing the classification of errors, know that systematic, random, absolute, mean absolute, everything relative. At last you will write x plus or minus 0.x like this. For example, we have written 71 plus or minus 2 or 71 plus or minus 1 kg. This is my true value, this is my the least count error. True value, this is true value, we will say. True value, least count error, I will write here. So 72 plus or minus 1 kg, it is unit, right? Unit. This is my true value. And this is my least count error. Least count error. Got it? Yeah. We will talk about the systematic error. Systematic error are the errors whose causes are known to us. Ante you are doing some work, you have done some mistake. So the mistake can be done knowingly by you or unknowingly by you. Okay, the mistake can be done by knowing or unknowingly by you. That two types are there, no, knowingly or unknowingly. In this, systematic errors are errors whose causes are known to us. That knowingly you are doing a mistake, no, that is called as systematic error, which means human mistake, like his mind has been disturbed with some other thing, due to that he is making more mistakes. Okay. Example, now based on the physics we are talking now, instrumental error due to errors, enormous errors, can be reduced by using more accurate instrument applying zero correction, which means ante you are doing a mistake when you are going to gym, which means you are lifting a weight. So suppose for biceps you are lifting something like casually, but when you are doing regularly, keep on doing, that time what will happen? You will rectify the mistake, you will reduce the mistake, right? The same thing we will do in the physics also. Errors due to neglection certain facts, example ignoring air resistance in pendulum experiment. In pendulum, no, here the pendulum will be oscillating like this. Now air resistance is there, like air is flowing like this. Okay, due to that also it can oscillate very slowly, but the original speed will be more, but due to air resistance, no, it will oscillate slowly. It can be like that also. And the errors due to environmental conditions like temperature, pressure, humidity, like due to the presence of the outside temperature, your room temperature can the system can show the high temperature or low temperature based on the outside surrounding temperatures, right? So based on that also, like, we can get the errors. So how to reduce that errors? Okay, that one we'll see. Now random errors. So random, the meaning itself, it says that the error done randomly. I don't know how I have done the error randomly. I don't know how I have done. The cause of random errors are not known to us. It is not possible to remove them completely, but I can reduce them. I can minimize them. But how to reduce, sir? How to minimize it, sir? They can or they may arise us due to variety of reasons. For example, sensitive balance reading disturbed by vibrations of the vehicles nearby. Then random error can be minimized by repeating the observation many times. So repeating the observation in the sense, here A1, A2, A3, A4 up to AN, everything is observation only. Everything is observation only. So you know how to take the mean, right? Mean means nothing but A1 plus A2 plus up to AN divide by how many values you have taken, that many values you should, that many times you should divide it. 5 values you have taken, divide by 5. 7 values you have taken, divide by 7. 10 values you have taken, divide by 10. For example, if I take 11, 13, 9, 7, 10, 15. How many values are there? 1, 2, 3, 4, 5, 6. I need to get the mean value. Mean value in the sense 11 plus 13 plus 9 plus 7 plus 10 plus 15. Divide by 6. So 11 plus 13, 24, 24 plus 9, 33, 33 plus 7, 40, 40 plus 10, 50, 50 plus 15, 55, 65. 65 by 6. Around how much will I get? 10? Yes, no, 10, around 10 point something, 65, no, so 6, 10 times in the sense how much? So 60, remaining 5.0, so 6 are 36, 7s are 42, 8s are 48, so 2 remaining, again 0, so I can get the value. How many decimals I want? I can get that many decimals, so which is nothing but 65 by 6 will be equals to 10.83. So this is my mean value. This is my mean value. I hope you got it right. So once again we will see whatever we have talked about in today's class. Yeah. So rounding of the numbers will talk. Okay, algebraic operation we have talked. So we'll talk about the rounding of numbers also once. So rounding of numbers have 3 rules. So rule number 1, if the number lying immediately to the right of the cutoff digit is less than 5, then cutoff digit remains unchanged, which means x equals to 6.24, right? So last number is less than 5, which means I can have 6.2, that's it. If it is more than 5, 6.24, last digit is less than 5, then cut it. I will get the value as 6.2. Suppose you are having 6.26, which means last digit is more than 5, then add plus 1 to the previous number, so 6.3. This two I hope you got it. If less than 5, leave as it is, keep the previous value as it is, and this one I should cut it. If it is more than 5, cut this one, but previous value I should add plus 1. If it is equal to 5, what I should do, sir? That is the trick here. If the cutoff digit is even, it remains unchanged. If the cutoff digit is odd, it is increased by 1. So we have taken example 6.25, 6.35 equal to 5. See the previous number, it is even or odd. If it is even, what I should do? Leave as it is. So 6.2 is my answer. If it is odd, increase by 1. So this is odd, increase this one by 1. So 6.4 you will get. Okay, this is about the rounding of the numbers. Got it? So with this, I'll conclude today's session of the rounding of the numbers, algebraic operation of significant figures, and some classification we have talked about the errors. And in tomorrow's class now we will talk about the remaining topic of the errors, and we will see some questions over there. So until then, I'll take a break from you guys. Thank you. Bye bye.